Okay, in this video we are going to talk about the mean, the mode and the median. Okay, so we have the mode, which is the most frequent. Piece of data, the median, which is the very middle of the data, or another way of putting this would be 50% through the data. And finally then we have the mean, which is actually probably the average that you're most common with or most familiar with, which would be the sum of all numbers. So all numbers added up together divided by the amount of numbers. So if I look at the following numbers, okay, so if I look at the numbers 7, 3, 9, 12, 3, 7, 8, 4, 7, 7. And let's say 10. Okay, so I have this set of numbers. From this set of numbers, if I want to find the mode, I'm looking for the number that shows up more than any other number. So we've got a 7, 7, 7, 7. So we've got 4 sevens, and we don't have 4 of any other number. We've got 2 3s, okay, but there are more 7s. So the mode is 7, okay. In this case, to find the median, okay, so if I want to find the median, I have to reorder these numbers. Okay, so I'm going to start off with the lowest. I now have 3, 3, 4. So scratch off the numbers that we use. We've got 3, 3, 4. We have 4 sevens, 7, 7, 7, and a 7. Scratch off all of those sevens. I have 1 8. I have a 9. I have a 10. And I have a 12. Okay, so really important that I am getting all of the numbers. And the median is the very middle number. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so what I could do here is I could say I have 11 numbers divided by 2 is 5.5. Okay, and I always round up. So I'm looking for the 6th number. Okay, so I've got 1, 2, 3, 4, 5 numbers. And then I have 1, 2, 3, 4, 5 numbers after the median. Okay. Another way of looking at the median, you could take a pen and knock 1 from the front, 1 from the back, 1 from the front, 1 from the back, 1 from the front, 1 from the back, and continue that. And eventually you will get your median. Okay. So the last one then is the mean. And for the mean, I need to add up all of these values. So I've got 7 plus 3 plus 9 plus 12 plus 3, 7. Okay. And I'll just add up all of those numbers. We've got 7. Okay, so if I'm right here, that would be 77. And I'm dividing it then by 11, because there are 11 numbers. And I get a mean of 7. Okay, so I have here in this case a mode of 7, a mean of 7, and a median of 7. Okay, now in this case, that all works out. Okay. So let's look at another set of data. Okay, sorry, bear with me. Okay, so let's look at another set of data. So this one, we're looking at house numbers. Okay, sorry, number of letters, we'll say number of letters delivered to houses on a road. Okay, so I have 2, 4, 5, 2, 30, 4, 4, 6, 6, 4, 6, and 5. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data here. Okay, so the first one I'm going to look at is the mode and see, is there a mode of this data? Sometimes there's not a mode because there's not a number that shows up more than the others. But here I have 1, 2, 3, 4 4s. I've got 2 5s. I've got 2 6s. I've got 2 2s. So the mode in this case would be 4. Okay. The mean of this data, or sorry, we'll go median first. The median of this data is the very middle. Okay, so a couple of ways of doing this. There are 12 pieces. So this time we have an even number of data. So if I have an even number of data, so I have 12 pieces of data, if I divide 12 by 2, I get exactly, if I divide 12 by 2, I get exactly 6. So that means I have 6 pieces of data, 1, 2, 3, 4, 5, 6, and then 6 pieces of data at the back. So my median has to lie in here. Okay, now I could also say, like the last time, scratch 1 from the front, 1 from the back, 1 from the front, 1 from the back, 1 from the front, 1 from the back, 1 from the front, back, and continue like this. Okay, and I still get that my median actually just lies right in there. Okay, right in the middle. Now in this case, it's nice and easy because it's both 4. So we've got 4 plus 4, which is 8, divided by 2 to get the middle, and it's still 4. So we actually still have a median equal to 4. Okay, and the median and the mode, by the way, are not always the same. They just happen to be in the last 2 examples. Okay, so to get if it's an even number, to get the median, you always add up the number in front of the line and after the line and divide it by 2 to get your median. Okay, last one we're going to look at then is the mean. Okay, so the mean is I'm adding up all of the numbers. So 2 plus 4 plus 5 plus 2 plus 30 plus 4 plus 4 plus 6 plus 6 plus 4 plus 6 plus 5. Okay, and if I add up all of these numbers, 5 plus 2 plus 30 plus 4 plus 4 plus 6 plus 6 plus 4 plus 5, I get 78. And remember, I have 12 pieces of data, so dividing it by 12, okay, and I get a median of 6.5. Okay, now my median is a little bit higher here than my mean, or my median and my mode, or my mean is a little bit higher. Okay, and usually the mean is a little bit higher because of an outlier. So this number 30 here is what we call an outlier. Okay, it's a very important key word here is an outlier. So an outlier doesn't fit in with the rest of the data. Okay, so if I was to not count this number 30 and I was to add up all of the other numbers, So let's do this in purple. So in this case, I am adding up 2 plus 4 plus 5 plus 2. I'm not adding in the 30. Plus 4 plus 4 plus 6 plus 6 plus 4 plus 6 plus 5. I get 48. And again, remember, I'm dividing that by 12. And then I actually get a value much more close to the median. Okay, so quite often the median is the most reliable when we have an outlier. So more reliable than mean if and only if we have an outlier. Okay, because if we have an outlier, generally that outlier will mean that the mean is a little bit higher, and we're not allowed to just discount it like I did here. I just did this as an example to show you, but the real value for the mean here is 6.5. Okay, we'd have to take all of the data into account to do the mean. Okay, right, let's look at just one more value here. Okay, so just one more example. Okay, this time I'm going to be told that the mean of the following numbers is 17. Okay, the numbers are 10, 15, 18, 12, 20, 22, X, and 15. Okay, so I have an unknown. And when we have unknowns, we've got to think about what we know. And I know that the mean is the sum of numbers divided by the amount of numbers is equal to the mean. Now in this case, I actually know what the mean is. I know that the mean is 17. So I know that the sum of all of these numbers divided by the amount of numbers, and I know that I've got 1, 2, 3, 4, 5, 6, 7, 8 numbers, is 17. Okay, so I know that some number divided by 8 is equal to 17. Okay, and always to get rid of a fraction, I can also remember that if I multiply, so if I multiply this side by 8, remember division and multiplication are the opposite of each other, so they cancel each other out. And my other rule of math says that what I do to one side, I have to do to the other. Brackets means multiply. So I now know that the sum of numbers has to be equal to 136. Okay, which means that when I add up all of my numbers, 10 plus 15 plus 18 plus 12 plus 20 plus 22 plus X plus 15, I will get 136. So if I add up these numbers, 10 plus 15 plus 18 plus 12 plus 20 plus 22 plus 15, I'll get, sorry now I'm going up here, 112 plus X, because remember I can't add the X because it's not a like term, would be equal to 136. Going back to my algebra, subtract 112 from both sides. So 136 minus 112, which means X is equal to 24. Okay, so X is equal to 24, which gives me a mean of 17. Okay.